Hey everybody, this is Jessica covering the first mini project, which for me was a max patch. This patch uses Markov objects, which may go a little beyond the scope of this course up to this point, but I learned how to use them in the Autonomous Music Systems class. And they use MIDI, so I went ahead and connected the dots there. So first things first, let's cover what Markov objects are and how they work. I'm going to be using the term training dataset a lot here, and that training dataset can be anything. It can be a professional piece of work, it can be something you wrote 5 minutes ago, it can be a few scales, it can be anything. As long as it's in the MIDI file format and it is tangible, we have access to it, we can use it. So then we're going to shove it through this Markov object. We can do that by hand, very painful process. So the computer has an object, the Max has an object, that Markov object that does this for us. And basically, what it does is it runs a statistical analysis on our training data set to see the probability of certain notes following other certain notes. Rough example, we have a C. In our training data set, a C is followed by a D, E, or F. In our training data set, C is never followed by G, A, or B. So our probabilities for G, A, and B following a C are going to be 0. And then the probabilities for the D, E, and F will correspond to whatever they are in the training data set. Fast forward, we build our model, the model runs that analysis, and then we're starting our new model. That model is going to follow those percentages. So a C in our new model will not be followed by a G, A, or B. And then a C will be followed by a D, E, or F, depending upon the percentages. So if F has the highest percentage, more often than not, C is going to be followed by F, but it will still be followed by D and E, just in fewer times because that percentage is smaller. So it's going to run through this patch as a standalone application, but I think I'm just going to break it down in the patcher mode so you don't have to see the same information twice in 2 different ways. This has a lot going on, but realistically I think is very simple, especially when we take into consideration that the computer is doing the Markov object for us. So this stuff on the left, let me ease your mind for just a few different objects here, has realistically no part of the Markov object. This is just outputting the file that we have. So I'm going to go ahead and read the file in first, as you saw in the patcher mode, or in the presentation mode in the standalone. That's the first step. So I'll go ahead and read the file in. I'm very, very happy to share this with you. It is a combination of, drumroll please, Jingle Bells and the introduction song to the Beverly Hillbillies. I couldn't think of any 2 pieces of music that would go better together. So I'll read that in. I'll go ahead, start 8000, just lets me play it through very quickly. We're going to unpack that. We're going to take the pitch and velocity. The velocity, basically, we're just taking that to be able to listen to the file itself. The pitch is what we're really after here, and that pitch is going to be sent into the Markov object, right? So as you saw in the standalone, after we do the start 8000, the next 2 steps are build and dump. This is why I really wanted to hit it on the back end, because they're just 2 buttons in the presentation mode, right? We go back here. What we're doing is we're building our Markov model that is shoving into there, and we are dumping that. So then when I come down here, I can show you what I was talking about earlier. All these notes here are the ones present. I ran it twice, so that's why there's 2 sets here. But all these notes here are what's present, right? So 0 through 13. That's the first set here. These are the notes present on the left side. You see 69, 67, 65, 64. Those are the MIDI correlations to the notes that we have. And then all these notes following are the notes that, the zeros are the ones that didn't happen, and then these other decimals are the percentages of those particular notes happening. I say that and now I think that I confused myself a little bit, but I just wanted to touch on the fact that this database, for lack of a better term, is here and we can look at it and see it visually. So basically the last step is to start the model, so we can start listening to what we just wrote. So hopefully I didn't just talk over that, but you heard a few notes string out after I started off, and you heard different velocities. So the different velocities comes from right here, random 127. So we're basically just allowing the computer to take those notes in the model and correlate that to a random velocity, and that's the output that we're going to get. Now, the trail of notes after I shut it off is from all these pipe objects, which just basically allows for a delay. So we're going to add a certain interval at a certain time after a note is played. So that note is in the Markov model. We're going to associate it with a random velocity, and then we are going to add certain intervals on it at certain delayed time frames. And that is basically the package then that is being sent to the node out.